Here we are determining whether the mean value theorem can be applied to f on the indicated interval. This is the formula that we're going to plug into at the end, and this is our function and this is our interval. So first, we're going to take the derivative of the function. So 2 comes in front, so it's 2x. Next, we're going to plug in these interval values into the original function. So -2 squared is 4, and then, oh, this is A and this is B. And then 1 squared is 1. Next, we're going to take this equation. So we have 2x, and we're going to change it to 2c to determine the value of c. And we're going to set it equal to b minus this value, a, over this b minus this a. Then when we reduce, this is going to be -3 over 3. This turns into 2c equal to -1, and then divide by 2. So c equals -1/2. And that's your value for c. Here's another example. So first we're going to check for discontinuities. We're going to plug in numbers from -2 to 2. So f of -2 equals 1 minus 2 over -2, which equals 1 plus 1 equals 2. Next, we're going to plug in -1, which equals 1 minus 2 over -1. So that's going to equal 1 plus 2 equal to 3. These are both continuous, so we can move 1 to 0. 1 minus 2 over 0. You cannot have a 0 in the denominator, so therefore the mean value theorem cannot be applied to this function, and it is discontinuous on this interval because 0 does not apply. Okay, so we're going to do an example of intermediate value theorem. So here we have the function x cubed plus 2x minus 1, and they give us the interval from 0 to 1. So we're going to use intermediate value theorem to show that this polynomial function has a 0 in this interval from 0 to 1. So that means that it's going to change from a positive value to a negative value, or a negative value to a positive value. So that's how you find the 0, because on a graph of a function, it'll go from negative to positive, like here to here, or here to here, to show that there's a 0 in one of these values. Alright, so to do this problem, the first thing we're going to do is plug in the interval values into the function. So f of 0, so we'll plug in 0 to all these x values. So we'll have 0 cubed plus 2 times 0 minus 1. And that equals -1. So f of 0 is less than 0. Next, we're going to plug in 1 into this function. So f of 1 equals 1 cubed plus 2 times 1 minus 1, which is going to be 1 plus 2 minus 1, which equals 2. So f of 1 is greater than 0. So you can see that from here it went from a negative value to a positive value. So because this function is continuous on this interval, intermediate value theorem will guarantee a value c which is between 0 to 1, because it changes from a negative to a positive value. Okay, we're going to do another example of intermediate intermediate value theorem, but this time we're going to use the bisection method, which means you're going to continually cut the value in half that you plug in to test in the function. So here's our function, x squared plus x minus 1. So first, let's start off with f of 1. So we plug in 1 into this function, and we'll have 1 squared plus 1 minus 1, which equals 1. So then, since we plugged in 1 here, we're going to cut this value in half using the bisection method. So that means we're going to plug in 0.5. So once we plug in 0.5, 1 into this function, and we'll have 1 squared plus 1 minus 1, which equals 1. So then, since we plugged in 1 here, we're going to cut this value in half using the bisection method. So that means we're going to plug in 0.5. So once we plug in 0.5, we'll have 0.5 squared plus 0.5 minus 1, which will equal negative 0.25. And here you can see that this went from a positive to a negative, so that means that there is going to be a 0 in this. Okay, so here's another example that we're going to use intermediate value theorem for. And the function they gave us is 3 minus the square root of 2x plus 4. Notice that they didn't give us an interval for this problem. So we're just going to start off and test values into the function. So let's start off with f of 0. So when we plug that in, we're going to have 3 minus 2, which equals 1, and that is greater than 0. So if we plug in f of 1, we'll have 3 minus the square root of 6, which is also greater than 0. Next, if we plug in f of 2, we'll have 3 minus the square root of 8, which is also greater than 8, which is also greater than 0. Next, we can plug in f of 3, and that will give us 3 minus the square root of 10, which is going to be less than 0. So notice how it went from a positive to a negative value here. So since this function is continuous for all values of x, where x is greater than or equal to negative 2, because then it would have been discontinuous, and f of 2, which is this, is greater than 0, and f of 3 is less than 0, intermediate value theorem will guarantee a value of c such that 2 is less than c and c is less than 3. So f of c equals 0.